My title is Instant Physics-Based Rendering. It's a dream I had a few years ago, and I'm going to kind of take you on the journey of how that has evolved up until today. And the other thing I'd like to say, one thing, a philosophy I have is a picture's worth 1,000 words and a video is probably worth 1,000,000 words. So two philosophies that are injected into the work we do. Okay, so as Alex mentioned, I'm from Lockheed Martin, specifically Rotary and Mission Systems in Morristown, New Jersey. And we're known as a world leader in systems integration. And we also are known for, in Morristown, New Jersey, manufacturing sophisticated radars. And while I mentioned the part about radars, as we go into the talk, I just want to point out that when we are manufacturing and integrating these radar systems, we have to deal with tolerances of 1/100th of an inch. So when we start talking about geometry and, hey, why don't you reduce that and make it run faster? We can't. We have to design to that tolerance. So that's why it's very important that any system we use supports very complex, detailed geometry. So this is actually an Iray rendering of our facility. And I know a few buildings don't have textures on them. And the story there is a colleague of mine and I were out one day taking pictures of the walls of the building, and security came up and said, "You can't take pictures here." So that's why some of the buildings don't have textures on. So I wear two hats. I work in ship integration and test, where we're tasked with integrating a combat system, very complex combat system, a lot of electronics, into a naval ship, both in the United States and internationally as well. And the other hat that I wear is I work in the Surface Navy Innovation Center, where we're looking at disruptive technology and how we can inject that into the business that we're in. And this is the lab that we work in, and this is actually the VR AR lab. And you can see that we do have quite a few GPUs in there, and we also, in the computer room, you can see we have 4 VCAs currently that we're using in there. All right, so this is our software suite, and so the way we have arrived here is we've been doing rendering of ships probably over 30 years, and we've gotten very good at getting the CAD data into the rendering. So we're very good at pulling the CAD data in directly, and in fact, for AutoCAD and Ship Constructor, which is a tool that sits on top of AutoCAD, we're able to import that directly into our software. So there's no convergence necessary, and it helps us maintain that tolerance that I mentioned, that 1/100th of an inch tolerance. And we also integrate CATIA directly into our software. But as you can see, we have a variety of software tools, but I just wanted to tell the story of how this all began. We were doing animations and rasterized rendering. And there's one gentleman who's no longer with us. He works in Fort Worth now. He made a bet with me that we couldn't get photorealistic real-time rendering within the next couple months, because we were about to make a big video. And has anyone ever visited Philadelphia? Anybody in Philadelphia? All right, well, in Philadelphia, one thing we're known for, cheesesteaks, right? So the bet was a cheesesteak. So I had 6 months to get real-time photorealistic rendering in, and we bet a cheesesteak. By the way, if you ever get to Philly, make sure you stop and get a cheesesteak. You probably could go get one in California, a Philadelphia cheesesteak in California, but So before I go into the story, here's a screenshot of what we call COMITS-Ray, which sits on top of Iray, and it has all the GUIs to support the features that we have. It has all the common things. We can do camera manipulation. We can click on parts, move them around. We have the tone mapper in there. We can make 360 panorama VR videos. We can do keyframe animation from this system. And there's a few other features in there that are specific to our ship integration and test work. All right, so fortunately, I actually think it was a little earlier than 2012. Or yeah, 2012, I went to SIGGRAPH and I met the Iray team. And I had to get this video done probably by November. So fortunately, I met the Iray team and we were able to collaborate, and I got the Iray software development kit. So it was a savior. It actually won me the cheesesteak bet. So that was historic for me, and we built this system on top of the Iray SDK. And if anyone ever wants to actually look at how simple that is, there was a talk given at GTC in 2015 by Martin Carl that kind of walks you through the steps of how you can get this instant physics-based rendering very simply, with a few steps. And so I believe this audience is all pretty familiar with Iray, so I don't have to go into too much detail here, but it's basically, if someone asked me for a description, I'd say it's a push button rendering solution, specifically path tracing. So if you feed it all the right information, you're going to get a great physics-based rendering solution. And there's multiple rendering modes that you can use. You can use the IRT mode, or you can use the photoreal mode. And the nice thing also that came along is the MDL system to define our materials and the V materials. So that just made all this work much more easier. And as you saw in the SNCC, we had a few VCAs in there. So what Iray did nicely is it scaled very well on those VCAs, especially photoreal. You know, Jensen mentioned, I don't know how many frames are rendered a year, 1 billion or something. We're a good percentage of that in the SNCC. And what was great now is we can, when we first did our first video, we had K6000s. We had about 10 of them. And we had all pieces of our animation running on all these different machines. It took us about a month to do the whole video. Now we could do something like that in 2 days with the 3 VCAs. And now that we have the 4th one on here, it's even probably faster than that. Here's how it works. If you give it great geometry, great materials, or very physically accurate materials, very accurate lighting, and we do use the IAS profiles, we bring those in. And you get all that information to Iray, you get a radiance and irradiance map, and then you apply the tone mapper to that, and you get a really final image, very nice final image. So we're able to do that through all the components up there. So we do a lot of work with, since we're integrating stuff into the naval ships, we have to go sometimes to shipyards and deliver a work package of here's what we have to take off the ship, and here's what we have to put on, and here's how you can do it efficiently. What we do is we create animations of these work packages to help with the team that's doing that, and it's very efficient and it's a big cost saver because there's no trial and error. It's pretty much already solved how to do the particular installation. So the other thing we do, this particular ship, we're actually the main contractor on, so we have the whole entire ship. We do crew familiarization. So we can take a crew before they ever go on to this particular ship and walk them through every space, get them familiar with where everything is, well before they actually get on it. And this is one of my favorite images, and I actually just did this by accident. I came upon this one. I was just moving around in real time, and I stopped here, and I kind of like this image. But it allows, once again, the crew to get very familiar with the ship before they ever get on. And denoising. So I should probably even update that one slide. I said 2 days. Probably now we're talking hours where we can get our animations done. The denoising has been awesome. I can't say enough about it. I was waiting for it, and I was really glad to see it get in. So this is just 4 iterations. So on the left is how noisy the image would look without denoising, and only after 4 images with denoising, it's pretty clear, pretty clean. The other thing we do is work package videos. So there's maintenance procedures that have to be done to repair a piece of equipment, we can create videos of that. Once again, it's the better it looks to the person using the video, the better it helps him get his job done. Also, 3D digital mockups. The gentleman from Ford was mentioning clay. We have people still that build real life to scale physical mockups, believe it or not. And we don't see any need for that, really, in our group. So we can do 3D digital mockups and do the HSI studies with these mockups. Next. And lighting analysis is another big use. So here's space in the ship where all the decision making goes on, and it's very important that we get the lighting in here correct. There's actually a MIL standard that says certain surfaces have to have so much light. And since we get the irradiance map, what we can do is we can use that. That's basically saying at each surface how much light is arriving. We can color code it to the lux, and we could put little probes and make sure that certain surfaces are meeting that requirement. And we also do ground-based buildings where we put some of our radars, and this is an example of that. And once again, we can lay out the whole space, the whole ground-based system, and now we could actually make a study of how the lighting at nighttime makes sure that it's properly lit, both in the nighttime, so that whatever it is that needs to be seen by the people operating the place, we have met that requirement. COMITS-Ray cloud. So our LMI, our network, is usually very slow. What we can do is we can hit a sweet spot of our network. Our network's very fast for video. So what we can do is we can use Iray server, and we could send images to people all over the world, and they can receive it on their laptop and get very high quality images, and they can have discussions and just discuss designs all over our LMI. And these are just some examples of some models that we've used for that. And recently, our business development people want to go on the road, and they went away to show our product. So what we can do is we can do the 360 VR panoramas. You get the device that you can slide your iPhone into, and they can go on the road and show 3D VR pretty much anywhere around the world. And Iray, we usually do them at 6,000 by 3,000. And it's nice to have Iray and the VCAs to do that. All right, so why Iray? Instant physics-based rendering without a lot of work. We get the denoising. We can bring on our full detailed models. We get really great anti-aliasing when we're creating videos, which I can't tell you how important that is. It's just so nice. The anti-aliasing is awesome. And here's some of the, from our point of view, some of the business gaps that it fills. So we can do arrangements, we can do lighting studies, we can do equipment load-up planning analysis, ship upgrade planning. We get the VR 360s, and most of all for us, we help reduce the product lifecycle cost, and our customer likes that. So I'd like to thank actually Chris Ecken, who's the director of the SNCC, who has been the incubator for all this great work. And my team, and Chris Crouch is actually in the audience, and the great NVIDIA people that helped along the way, and of course my mentors. Thank you.